Welcome everybody to the fourth video of this Geometry Chapter 4 sequence. Today we're going to be working on section 4.4. We're going to be talking about angle, side, angle, congruence, postulate, and the angle side theorem. So we're trying to prove today that triangles are congruent using this postulate and this theorem. It will be very similar to the last section, but we're just learning two new theorems today. So the first postulate we're going to learn is the angle, side, angle congruence postulate. And similarly to the last section, there is one key word that I want to highlight in this definition. That's the word included. So the postulate states if there are two angles and one included side on one triangle that are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So it's crucial for you to understand the concept about this included side. And once again, I'll remind you, if it's easy to think about it, think about this. Okay, we're talking about angle, side, angle. So the side needs to be in between the A and the A, or the angles and the angles. So in this diagram here, we have angle A, which is congruent to angle D, angle C, which is congruent to angle F, and then we have this congruent side here of AC and DF. Notice that these are included in between the two angles. The next theorem we're going to talk about is the angle-side congruence theorem. So this theorem uses the word included, but this time we're talking about the non-included side. So once again, you can think about it the same way. The S is kind of not included here. It's hanging out on the side. It's not in between. So we know that's a non-included S. It's not in between the A and the A. This time it's not included. It's outside of the angle and the angle. So this theorem states that if two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So let's look at the diagram. So once again, we have angle A, which is congruent to angle D. We have angle C, which is congruent to angle F, and then we have the non-included side BC, which is congruent to the non-included side EF. So the included side here would be AC and DF. But if we're talking about the angle side, we're really focused on the non-included sides here. Let's do some practice with these. So, is it possible to prove that the triangles are congruent? If so, state the postulate or theorem you would use. Let's explain our reasoning. So for some of these drawings, it will be helpful to separate them similarly to the last section, but for some of these, we can just see it by looking at them. So let's look at practice problem A. So far, for these triangles, we know that side EF is congruent to side HJ. We know that angle E is congruent to angle J. Now we can look at this diagram and we can also conclude that this angle and this angle here need to be congruent because of the vertical angles theorem. So then I'll specifically say that angle FGE is congruent to angle HGJ. So I have two angles and the non-included side. So side EF is the non-included here, and side HJ is not included here. So these are congruent because of the angle side congruence theorem. Okay, let me just give us some space here. Okay, so for this next one, I'm going to do B up here. So once again, I want to separate these to show you guys what's really happening here. So I have this triangle here off to the left, NPM, and I'm going to have my triangle off to the right, and this will still be N, this will still be P, but now this is Q. So we know that side N is congruent, side NP is congruent to side NP, and they tell us that MP is congruent to NQ. Now, we have no other way of deriving any information off of these triangles. So, it's not possible to prove that these are congruent. So, not enough info. Sorry about that enough, it doesn't look too good. Let me erase that. We'll just say not possible. It's easier to write that. Okay, so this last one here, this one's a little different because now we have these arrows. And we know that these arrows indicate that some of these triangles are, some of these lines are going to be parallel. So, let's separate those lines and let's redraw these triangles. So I have triangle UWZ, and then I have my triangle over here, ZWX. Okay, so the first thing we can identify here is that side WZ is going to be congruent to WZ. Now, since these lines are parallel, there's a few things that we know here. We know that angle 3 is going to be congruent to angle 1 because of alternate interior angles. So I'll highlight that here and say those two are congruent. But we also know that 2 needs to be congruent to 4 for the same reason, alternate interior angles. But actually I'll do the double line to differentiate. So let's look at our diagram here. We have an angle, a side, and an angle. An angle, a side, and an angle. So the angle, side, angle congruence theorem, congruence postulate is what helps us say that these two are congruent. Okay, so let's get to some proofs. So once again, sorry about that. We're given two triangles here, and we need to prove that they're congruent. So first thing we're going to do, sorry about that. First thing we're going to do, we're going to create our statements and our reasons column. So once we have our statement and our reason column, we're going to look at our diagram and we're going to jot down our givens. So what's given to us here is that this side BC is congruent to this side EC. So we're going to say side BC is congruent to side EC. And we also know that angle B is congruent to angle E. And we have those two angles right here. They're both right angles. So this is all given to us. So we have an angle, a side, and we need to either find another angle that's included or another angle that's not included. But as you started to see, if we ever see something like this, we know that these two angles are congruent because they're vertical angles. So I'm going to state that angle, and I need to be specific here because just saying angle C isn't enough, because angle C could apply to this one or this one. So you need to be very specific when you're talking about this angle right here. So it's angle ECD is congruent to angle ACB. And we know this because of the vertical angles theorem. So now we have an angle, a side, and another angle. So we have angle, side, angle now. And that's enough to prove that these two are congruent. So we have triangle ABC is congruent to triangle DEC because of the angle, side angle congruence postulate. Okay, good. Alright, so we'll do one more. I'll do one more with you, and then the next one I want you to try on your own, and then you can come back and you'll see how we do it together. So, let's make our statements in our reasons column. So we have our statements and our reasons. So for this one, what you need to realize is there's actually two triangles here. I'll highlight the first one. It's this triangle here. And we also have this triangle here. So what I'm going to do is, I like to separate these because it actually helps me see them a little clearer. So let's do that. So we're going to have our first triangle here and our second triangle here. So we have C, E, and A. And then we have B, A, and D. So we know that this bottom DA is congruent to this bottom AE. We also know that angle C up here is congruent to this angle over here. Now, this angle A is the same for both of these triangles. So we can say that those two are congruent as well. And there we go. We have angle, angle, side, angle, angle, side. So we see that in drawing. Now let's put that in proof form. So the first statement we're going to say is that AD is congruent to AE. This is given to us. And it's also given to us that angle B is congruent to angle C. That's still in our givens. Okay, so the next thing we want to say is we want to talk about this angle A. So we want to say angle A is congruent to angle A because of the reflexive property. Remember, the reflexive property says anything needs to equal itself. So we can say angle A equals angle A. Then we have a side, an angle, and another angle. So that's enough to say that triangle ABD is congruent to triangle ACE because of the angle, angle, side congruence postulate. Okay? Not so bad, right? Good job. Alright, this one's very similar to the first one, so I think I'm actually going to skip one. Okay, this one's good. So what we'll do for this one is I'll start you off. I'll write probably the first two steps, and then I'll want you to complete it, and then we can talk about this one together in class. So, take a second, pause the video, and see if you can work through this one on your own. Alright, so let's come back and let's at least get you guys started on this one, and then we can finish this one in class if you really struggle with it. But I'm sure you'll do fine with this one. So let's make our statements and our reasons columns. And then let's look at what we have going on in our diagram. So they tell us that angle G is congruent to angle B. They tell us that line GA is parallel to CB, and that's all they tell us for now. So let's write that down in our proofs. So our given, we know angle G is congruent to angle B, and that's given. And we also know that line CB is parallel to line GA. That's in our given. Now let's think about the implications of this. So if this line is parallel with this line, we have this transversal of CA. So we learned about parallel lines. We learned that these two angles are going to be congruent to each other because of alternate interior angles. So I'm going to specifically state this angle right here first. Angle BCA is congruent to GAC because of alternate interior angles. Alright, well, I'm going to leave it there. I think you guys can work through this last step. There's one more thing you need to prove before you can say these two triangles are congruent. So I'll leave you with that, and we'll talk about that one in class together. Alright, and that's our lesson. Once again, thank you. Guys, keep working hard on this. Remember, if it was easy, anybody would do it. So work hard on these proofs. I know they're difficult, but we're going to work through them together. Okay? Stay positive, stay confident, and I'll see you later.